Hey everyone, welcome back. In the last video, we started learning Python data structure, lists, and tuples. In this video, we'll continue with dictionaries and sets. Dictionaries are one of the most widely used and important data structures in Python. Data professionals use dictionaries to analyze large data sets with fast processing power. This helps them gather and transform user information. Dictionaries also provide a straightforward way to store data, making it easier for users to find specific information. A dictionary is a data structure that consists of a collection of key-value pairs. They are instantiated with braces or the dict function. To use dictionary, you look at the key, which will let you access the values associated with that key. That's what's meant by key-value pairs. Here's a simple example to illustrate the concept. Suppose we have a customer info, and the customer info has different information about the customer. We could have a dictionary that stores this information for us with ID, is VIP, and wallet as keys, and the corresponding information as values. We could use this dictionary to look up for a specific info. For example, if we want to know what the customer's ID is, we type the name of the dictionary, customer info, followed by the ID key in brackets. Accessing a dictionary this way always searches over the keys and returns the values of the corresponding key. It doesn't work the other way around. I can't use indexing to search for ID value and find out their key in the dictionary. I will get a key error because ID value is not a key in the dictionary. Dictionaries are instantiated mainly in two ways. The first way is with braces. With this approach, each key is separated from its value by a colon, and each key-value pair is separated from the next by a comma. The second way to create a dictionary is with the dict function. When using the dict function, the syntax is a little different. When the keys are strings, you can type them as keyword arguments. The last time we made this dictionary, we used quotation marks to indicate that the keys were strings. Here we don't because they're keyword arguments. Also, instead of using a colon between the keys and their values, you use an equal sign. Notice that the key ID is turned to green after we remove the quotation marks. Remember why that happened? Right, because the ID word is a reserved word in Python. It means you cannot use it as when naming a variable. So we'll change it to customer ID. The dictionary lookup is the same, irrespective of whether braces or the dict function is used. The dict function is also a little more flexible in how it can be used. For example, we can create this same dictionary once again by passing a list of lists as an argument, or even a list of tools, a tuple of tuples, or a tuple of lists. They all give us the same result. If we want to add a new key-value pair to an existing dictionary, say to put gold value in member type key, we can assign it like this. A dictionary's keys must be immutable. Immutable keys include, but are not limited to, integers, floats, tuples, and strings. Lists, sets, and other dictionaries are not included in this category, since they are mutable. Another important thing to note about dictionaries is that they're unordered. That means you can't access them by referencing a positional index. If I try to access our customer info dictionary at index 2, I get a key error because the computer is interpreting the 2 as a dictionary key, not as an index. Finally, you can check if a keyword exists in your dictionary simply by using the in keyword. Note that this only works for keys. You can't check for values this way. Now, let's learn about some useful methods that we can use on dictionaries to really take advantage of their power. Specifically, we'll discuss the keys, values, and items methods. If you run a loop over a dictionary, the loop will only access the keys, not the values. We will go through later in future videos about iteration and loops. But you don't need to write a loop every time you want to access the keys of your dictionary. That's what the keys method is for. The keys method lets you retrieve only the dictionary's keys. Returning to our customer info dictionary, when we apply the keys method to the dictionary, the computer will basically list out our key. ID is VIP, wallet, and member type. In a similar way, the values method lets you retrieve only the dictionary's values. When applied to our customer info dictionary, we get the values returned as a list. In this case, you can see here we have the ID value. True, 147.23, and then gold. Since our values are lists of tuples, it means the result of calling this method is a list of lists of tuples. But what if you want to access both the keys and their values? You can, using the items method, which lets you retrieve both the dictionary's keys and values. Dictionaries make storing and retrieving data fast and efficient. Keep exploring the many things you can do with them. With time, you'll find that they become an important tool in your data analytics toolbox. We're going to discover sets. A set is a data structure in Python that contains only unordered, non-interchangeable elements. Sets are instantiated with the set, function, or non-empty braces. Each set element is unique and immutable. However, the set itself is mutable. Sets are valuable when storing mixed data in a single row or a record in a data table. They're also frequently used when storing a lot of elements, and you want to be certain that each one is only present once. Because sets are mutable, they cannot be used as keys in a dictionary. The first way is with the set function. The set function takes an iterable as an argument and returns a new set object. Let's examine the behavior of sets by passing lists, tuples, and strings through the set function. Let's examine the behavior of sets by passing lists, tuples, and strings through the set function. To turn the list containing red, green, blue, and green into a set, pass a list through the set function. And notice, the list loses the second green. As I've mentioned, each element must be unique in sets. Pass a tuple through the set function using two sets of parentheses. One to tell the computer that the data we are working with is a tuple. The other because the set function only takes a single argument. Again, the same result, only one green element can be present in the set. Finally, pass a string through the set function. It doesn't return the string, just the singular occurrence of the letters in the string, E, G, N, and R, in an unordered way. This is because the set function accepts a single argument, and that argument must be iterable. A string is iterable, so the set function splits it into individual characters and keeps only the unique ones. The second way to instantiate a set is with braces. However, you have to put something inside the braces. Otherwise, the computer will interpret your empty braces as a dictionary. Note here that instantiating a set with braces treats what's inside the braces as literals. So when instantiating a set of only a single string using braces, it returns a set with a single element, and the element is the string itself. Remember, to define an empty set or a new set, it is best to use the set function. You can only use curly braces when the set is not empty and you are assigning the set to a variable. Also, keep in mind that because the elements inside a set are immutable, a set cannot be indexed or sliced. Now, let's discuss some additional functions you can use on sets. First, intersection finds the elements that two sets have in common. Union finds all the elements from both sets. Difference finds the elements present in one set, but not the other. And symmetric difference finds elements from both sets that are mutually not present in the other. Python provides built-in methods for performing each of these functions. Let's start with the intersection method, denoted by the ampersand. First, define two sets. Then, apply the intersection function, either by attaching the intersection method to set 1 and passing set 2 to the method's argument, or by using the ampersand operator. Great! Now, let's apply the union function. Use braces to define the two sets, colors 1 and colors 2. The goal is to observe where they overlap. Print them using the union method on the colors 2 variable or the union operator symbol. Union is a commutative operation in mathematics, so the overlapping values will be the same, no matter what order you put your variables in. The difference operation on sets, however, is not a commutative operation. Just like in math, if you subtract 5 from 7, you get a different result than if you subtract 7 from 5. You can use either the difference method or the minus sign as a set operator. Subtracting set 2 from set 1 gives us only the elements in set 1 that are not shared with set 2. But we don't know if set 2 contains any elements that are not shared with set 1. The inverse is also true. Subtracting set 1 from set 2 gives us only the elements in set 2 that are not shared with set 1. But we don't know if set 1 contains any elements that are not shared with set 2. To get around this and observe the difference between two sets mutually, use the symmetric difference function. As you might have guessed, you can use the symmetric difference method or the symmetric difference operator, expressed by caret. Symmetric difference outputs all the elements that the two sets do not share. Excellent work with sets in Python. You've learned so much about dictionaries and sets in this video of the course already. And everything you're learning is preparing you for a really rewarding career working with data. That's all for now. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, we will learn about functions in Python. Thanks for watching. Can't wait to be with you soon again.